and then we got to make up a couple of quizzes. Okay. All right, here we go. Are you ready? Are you ready? All right, so this should say B. We're on letter B now. Okay. And so it says, what is the pH when 100 milliliters of 1 molar HCl is added to the solution? When I see that, you know what I cross out? Cl, and I say, oh, I'm adding in some H+. I'm adding in some H+. All right, so here, let's draw our picture back. Let's put our picture back of our beaker. 500 milliliters. It contains 0.3 moles of the acid and 0.2 moles of the base. Yes? Yes? Okay, and what you're going to add to it is that volume times that molarity. You're going to be adding in 0.1 mole of H+. Agreed? Because if you say 0.1 liter times 1 molar, don't you get 0.1 moles? Okay, so I'm adding in 0.1 mole of H+ to that beaker. There's your picture. And you got 2 gobblers waiting to gobble it up to protect the buffer. Now, who's going to gobble up H+? Between those two, who's going to gobble up react with H+? F-. So this is what you're going to write down. H+ is coming in. F- goes, I got it. My job. I'll take care of this H+. I got your back, cuz. Got your back. HF. It's a complete reaction. And why is it a complete reaction? Because I'm adding strong acid. That drives a reaction with a single arrow to completion. So I'm putting in 0.1. I had already 0.2 and 0.3. Agreed? Isn't that what I already had in my beaker? And I'm adding in this foreign object. It's going to get gobbled up by the F-. All right, so that's what I have. Now let's show how it changes to reach an ending. And an ending in an ice chart means somebody becomes 0 on the left side. Did you get that? And an ice chart with an ending means somebody becomes 0 on the left side. It's going to keep reacting until the limiting reactant is born. Who's my limiting reactant, H+ or F-? H+ is my limiting reactant. Only have 0.1 mole of him, and I've got 0.2 moles of that. So gobble, gobble, 0.1. If you're going to get rid of the 0.1 moles of H+, how many moles are you going to get rid of F-? Also 0.1, because of a 1-to-1 mole relationship. How many HF moles are you going to be making? 0.1. 0. Oh, buffer did his job. He gobbled up all that H+ that was added. Now, what did the F- end up doing to himself, though? Sacrificing some of himself for the buffer. Sacrificing some of himself for the buffer. And now, instead of having a 0.3 over 0.2 ratio, I got a 0.4 over a 0.1 ratio. So here's what you do. When you're finished with the gobbling, you stop, you look and you listen. What do you have? What do you have? You have F- and HF. What do you have? You have a buffer still. What equation comes to mind if you have a buffer? HH. That's how I solve for the pH. Matthew. HH says Ka times weak acid over conjugate base equals H+. Yes, does it not? It does. So I just do another little plug and chug. The only thing that's changed is this is now 0.4 and this is 0.1. So 6.9 times 10 to the minus 4 times 0.4 over 0.1. Do I really need to worry about the volume since the volume's all the same? I don't. I can if I want to. I can if I have to. I don't want to if I don't have to, because it's a little bit easier just to do that. Now, Abby, remember a second ago you said, how did you get 10 point whatever? Okay. What is 7 times 4? 28. So I'd write that as 28 times 10 to the negative 4 is what I write that as if I didn't have a calculator. But I do have a calculator. I'm just saying if I didn't. Okay. And that's how I'm going to figure out h plus. And then how do I get pH? Negative log it. pH is going to go up. Excuse me. pH is going to go down a little bit from what it was before because I added in some h plus. So it's not going to change a whole lot because the buffer did its job. The buffer did its job. What if you add in OH minus? pH will go back up a little bit. Is it basically going to be the same concept happening, just with HF and OH minus instead of H plus and F minus? You're writing this down, right, on your paper. So you got something to look at. Well, it's going to be on video for you to take it all in a second time and go watch it on YouTube. All right, here we go. Ready or not, here we come. We got a base one now. All right, so it's the same problem, but now we're adding in some OH minus. It's a buffer, and the buffer is having OH minus added to it, or attacking it, if you will. And what you're doing is you're attacking 0.01 liters of a 1 molar NaOH. So you're putting in 0.01 moles of OH minus into what? My same original beaker that's got my same original buffer in it. You don't ever change that unless they tell you to change it. Now, we'll tell you this. If I were to use half of the buffer, I'd have half of the moles. Molarity wouldn't change, but I would have half of the moles if I used half of the buffer. If I took 250 milliliters of my buffer out, I'd be taking half of the moles only out and leaving the other half behind. You do that when you pour some Coca-Cola that's got phosphoric acid in it this week and carbonic acid in it this week. When you pour some Coca-Cola from the bottle into a glass, you're only taking a portion of the pieces, right? Same thing with the buffer. If you take half the buffer, you're only taking half the moles out. Just saying in case you encounter that. All right, so 0.01 moles of OH minus added. All right, so here comes the OH minus. Who's going to gobble him up? HF. And when that gets gobbled up, what are you going to make? F minus and H2O. Make F minus and H2O. All right, you're starting with 0.2 and 0.3, and you're adding in 0.01. Michael, you with me writing it down? Got to have your notes. Otherwise, you got to go watch the video 50 times to get it right. All right, what value do I subtract from both guys on the left? The smaller the 2, because it's always going to be 1 to 1. The smaller the 2, minus 0.01, minus 0.01, plus 0.01. It's kind of like x's, but I know what my x value is, yes? So 0.21 moles over here. You writing it down? And 0.29 moles over here. And nothing over there. Oh, buffer did its job. Buffer did its job. Now I tell you to stop, look, and listen. What do you have? I still have a buffer. The buffer did its job, and I still have a buffer. How do I find pH? Okay, HH, Ka times acid over base. So I come up here and I say Ka times the acid part, 0.29, over the base part, 0.20, equals H plus. I added an OH minus, so my pH is going to be a little bit higher than it was originally. It's going to be a little bit higher. That is going to equal H plus, and all I have to do is minus log my H plus. Now, I'd give y'all a problem if we had time to do that. I was going to let you try it and give you a problem so you could try it. Those that came to my study session yesterday after school, they got to try their own and do their own. Because I felt the love. They were here, 3 of them, out of the 50-something. All right, so next week, Dr. Avila has said Tuesday there's a quick meeting after school, which is not my day, but so what we can do is this. My original plan was to give you both Monday and Tuesday, and we can still do Tuesday because we said it's going to be a little brief. Y'all just have to sit here and wait for me. But Monday, I'll be here Monday until 3:30, so I'll give you a good solid hour, 10 minutes on Monday, and then on Tuesday, I'll probably be back in the room by 2:35. I'm thinking at the latest, yeah, 30, and then I'll give you 2 or 4 on Tuesday. To get reviewed for your test on Thursday. Thursday for you, that's right. Thursday for you. Thursday for you. Wednesday's my regular study session, so it'll have to be Monday and Tuesday. Yeah. Your review sheet, which we're not quite ready for yet, but on the back of that has to be delivery number 4, okay? Al is up and running, get going. It's due for you, I believe, Monday night. Yep. Monday night, bye. Rosie, we were talking about you study block. Where are you going to school? Are you really? One of my best Sunday school students went to Campbell, and now he's in grad school getting his law degree at UNC. You might fall in love with North Carolina when you go down there to North Carolina to go to school. It's real nice. Yeah. Are you playing here? Yeah. Muzzle off the yeah. What we're talking about, I think it was Tyler, Ryan, that's the freshman. Oh, yeah, he plays soccer. Yeah, I didn't know that. Oh, well. Yeah, maybe not. He might, I think he might be on varsity. Really? I'm so weak.